How do space strategy and market development shape the future of defence and civil innovation? Well, today I've got the pleasure of diving into this fascinating topic with Liz Seward, Head of Space Strategy and Market Development at BAE Systems. And with over 20 years' experience in the space sector, Elizabeth has played pivotal roles in projects ranging from ExoMars rover study to a mission aimed at returning a sample from an asteroid. Incredibly exciting and cool stuff, isn't it? And she also brings a wealth of knowledge from her time at Airbus Defence, not to mention her extensive involvement with the International Astronautical Federation. Great Scott! So in our conversation today, we're going to explore the role of space in defence, the critical importance of Earth observation, and how near real-time intelligence is becoming a game-changer for multi-domain operations. And we'll also dive into BAE's innovative Azalea project, which leverages machine learning for enhanced data analytics, and discuss the implications of dual-use space capabilities for the UK and beyond. But most excitingly of all, we're also going to touch on the urgent need for a talent renaissance in the space age, all of which is going to be highlighted by BAE's launch of the UK's first ever space engineering apprenticeship programme. How cool is that? So buckle up and hold on tight as I beam your ears all the way to the UK, where you can join me in embarking on this journey with Liz to understand how space technology is transforming our world and also what the future holds for this exciting field. So a massive warm welcome to the show, Liz. Can you tell everyone listening a little about who you are and what you do?
Hi, thank you very much. I'm Liz Seward. I work for BAE Systems as the Head of Space Strategy. I joined the company 2 years ago now to help shape the future of where we're going in the space industry. BAE Systems is a big defence company, but hasn't been active in the space sector for about the last 20 years, in fact, in a major way.
And as soon as you mentioned the word space, I feel like a 12-year-old boy again, all of a sudden full of wonder. So just to set the scene for our conversation today, because I know when we mention space, it brings up so many different things for so many different people. So can you tell everyone listening a little bit more about the role of space in defence and indeed the need for Earth observation and real-time intelligence for multi-domain operations? Because we're all guilty of looking up at the skies and wondering what's going on up there. But we don't often think about looking back down on the Earth and some of the great work that people are doing and the technology that they're using to do that. We don't hear about that very much, do we?
We use space, so much in everyday life. And
Yeah.
As you said, looking down is that huge benefit we get from using satellites and using spacecraft. We can put a satellite up into orbit, and depending on how you launch it, where you launch it, you can either find the right height, basically the right orbit, so that you have your satellite hovering over the equator. It's how all satellite TV works. The dish points in one direction on the side of your house, and it never has to move because the satellite, in effect, hangs in the sky above it. So you can either get that constant view, but that's quite far away, or we have what we call low Earth orbiting satellites. They're much closer in, and they go around the Earth about once every 90 minutes. If you are looking up and stargazing, those are what you see going overhead. If you see sort of a star that moves at a constant speed across the sky, it's not a star, it'll be a satellite. And what that does is it gives us this global picture very rapidly. So you can see the whole world in a couple of days. If you put more satellites up, you can get that time down so that you can be constantly looking at what's going on below. We've used it for years and years and years for weather forecasting. And for the last couple of decades, it's been used for mapping, for Earth observation, as you said, for communications and connectivity. So there's a heap of activities that we use space for and satellites for. And yes, as you say, it's very exciting. It gives a view you can't get anywhere else. And it works for defence in being able to see over the hill, the horizon, keeping sort of constant monitoring. It's both looking at what people are doing. It's using radar to sort of see through clouds and see pictures of the Earth at nighttime. I mean, you can pick up different signals from places and see what's happening. We use it for weather forecasting. We use it for communications and connectivity. And so, yeah, there's an awful lot we use space for today.
We really do. And I know we're coming up to the Olympic Games. I think it was the 1964 Olympic Games where satellite first came and allowed people to see events as they happened all around the world at the same time. It's phenomenal, isn't it? And we do take a lot of that for granted sometimes, I think, as well as things like satellite navigation, of course.
Yes, I mean, we call it sat-nav, but we don't always remember that it stands for satellite navigation, and you are connecting to satellites in the sky as you do it.
And as for yourselves at BAE Systems, how are you integrating space technology into things like defence strategies? Is there anything you can share around that?
As you say, are a defence company and have been working in defence for the UK and internationally for a very long time. We have been doing some space activities over that time. We use our communications knowledge and expertise. And one of the originator companies of BAE Systems was, in fact, Marconi, the man that invented the radio. So we've got some really specialist technologies in things like waveforms, electronics, antennas, and digital signal processing. We use that in various ways. We actually build the deep space modem for the European Space Agency that controls their satellites around other planets, and have been doing that for a long time. And then we've expanded that knowledge out into some of our new programs. So we've got something called Azalea, which I think we'll talk about a bit more, and are building some satellites around that. But we're also connecting into other bits of the company, as you said. Where can we bring those space technologies and capabilities into some of the defence work that we're doing? A lot of it is around, we call it ISR, intelligence, surveillance and reconnaissance, those global images, that global knowledge that we can then feed into existing technologies and existing systems. Some of it is more of a backup. Can you use a satellite if you're on the battlefield to provide sort of connections and connectivity if you lose something else? So there's a lot of places where it fits and a lot of things that we can do.
And before you came on the podcast, I was doing a little research on some of the work that you're doing. And one of the things that stood out to me was the Azalea project, which you mentioned a few moments ago there. It appears to be a significant advancement in space technology. But for people listening that have not heard of it, can you just explain its multi-sensor capabilities and how machine learning, we've done well to get this far into a tech podcast without mentioning machine learning, but also how machine learning is employed to enhance data analytics with that too?
So what we've done is we've taken something that we do for our customers in ground-based comms and connectivity. And when we looked at how can we take this really interesting piece of kit, which is our software-defined radio, a radio you can reprogram, combined it with a data processor, then put it up in orbit and add in other sensors and technologies. And so our Azalea Cluster 1 that we're building now will launch next year. It has some radio frequency sensors, and we're combining it with a SAR, a synthetic aperture radar, and our unit, our software-defined radio and data processor. What this means is you can take a radio capture and a radar image and then use that onboard processing to do immediate analysis to find out sort of information rather than just send the raw data back to be processed. And the aim is to really reduce that time it takes to get information that's useful to an operator and really speed up that processing chain that we have. And the longer term vision is to add in even more sensors and combine it with optical pictures, hyperspectral, infrared, and then really get that sort of very rich picture, but much faster than we do today. There's some amazing capabilities that exist already in terms of layering this different data. And then what we're doing is really reducing the time that you do that with machine learning, onboard processing on the satellite so that you can ping down that first information much, much quicker.
And with the continuous evolution of space technologies, I'm curious, how does BAE Systems envision the future of innovation in space? And when I say that, I mean specifically, how can UK leverage dual use of space capabilities for both civilian and defence purposes too? Because there's so much different aspects to this, isn't there?
Yes, there is. I mean, dual use is a topic that we're hearing a lot about. It's something that we have highlighted as one of those sort of defence technologies to watch. It's something that it ought to be simple. It's, can you use the same system for defence and civil purposes? But in fact, it is actually much harder to do in practice, not really for the space-based reasons. It's harder because in many countries, the defence needs and the civil needs are slightly different, enough to make having the same system not quite meet either need. They also have very different security requirements, as you can imagine. You need that very clear assurance of your data and that knowledge that what you see or infer is true in the defence world, in a way that maybe you could be a bit more flexible in a civil world. They often have different timeliness needs as well. And they often have different budgets. Some of it comes down to the very simple politics of who can pay for what and how can you combine things together. But we are seeing lots of those problems being solved. And we are seeing that with the evolving systems, because we can reprogram what they do, you can meet different needs at different times, and you can have that dual use aspect. We also have the ability to put security in some parts of a system and not in others, so that you can have different customers using the same system, meeting all of their needs. And so we are moving much more into this dual use world. Lots of this capability is new, or is at least new in space. And so that's where some of that innovation comes in, doing it differently, adapting and being able to reprogram satellites on orbit. So using those software defined radios to change what something sees or listens to, and how it works, is really changing how we use satellites for this.
And another thing that stood out for me was the concept of a talent renaissance. Feels like a real transformative shift that's occurring in the industry. So on that side of things, can I ask what prompted BAE Systems to launch the UK's first ever space apprenticeship? Sounds incredibly cool. And also, what unique opportunities does that programme offer to participants?
The space apprenticeship is very exciting indeed. Yeah. So we'll have the first cohort arriving later this year, and it's a way to get a degree in space engineering without going to university, but by doing it through on-the-job learning, working at a company, but being released to university. So our scheme is done with the University of Portsmouth. And so you do a sort of a part-time degree and part-time working. The benefit and the reason that we're very passionate about it is people learn in very different ways. And so for those people that really hands-on, seeing the application of what you're learning as you're learning it, those are those people that really benefit from an apprenticeship. And as a company, we have an awful lot of apprentices. I think the number was over 4,000. So it's something that we're really passionate and proud that we do well. We're doing it because there are not enough engineers being trained at the minute to meet the needs of the nation across all sectors. And even in space, lots of people enjoy working in space because, as you say, it's very exciting. But we still don't have enough people in the industry. So anything we can do to bring more people in, to get more people sort of excited and working in space, then that's something that we need to do.
100%. And I will be asking you for where people can find out more information about that. You can only improve what you measure there, of course. So how does BAE Systems measure the success of its space projects like Azalea in terms of technological achievements and contributions to the UK defence capabilities?
In many different ways. Some of the success is, do we launch and does it work? The very basics. But really, it is, are we delivering for our customers? If we can find something that the customer doesn't have but needs, and give it to them. And our key customer as a company is the UK. We're very proud to be a British company, and we do a lot of work with the UK and UK government. And so if we can provide something for the UK and the UK citizens that is a step change and something different that they need, then that's a huge success for us. And then beyond that, we have an international footprint. We work in some really wonderful countries. And so we then look at, can we use that same system and deliver internationally as well? So that's our main success is can we give our customers something that they don't have yet or today and that they really need?
And if we were to zoom out for a moment, look at that broader space industry that we're talking about today, what would you say are the main technological or regulatory hurdles that you believe might need to be addressed before you can accelerate innovation in space? Because, again, it's a very complex landscape, isn't it?
It is indeed. I mean, the regulatory side would take up a whole other podcast. We're doing new things in space all the time. We're seeing commercial space stations being designed, people bringing back things that have been built in space. There are companies looking at asteroid mining. We're looking at reprogrammable satellites. There's so many changes happening that the regulation is really having to run fast to keep up. And so the UK as a country and through the Space Agency and other work we're doing is working really hard to make sure that they have all that right regulatory frameworks in place to allow all of this innovation to happen, but in a safe way, so that it's also monitored as well. And that's a very careful balancing act. And we're really pleased that we've got some experts within the organisation who are working on different programmes and supporting the government around this. One topic that's key is around space sustainability and sort of space debris, and making sure that we are responsible contractors and that we are not going to pollute the space environment, because we've got to make sure that it remains safe for many years to come. And we've got one of our lawyers, James Pearson, is part of the UK programme around that, looking at how can we make sure that everybody has to meet certain standards so that we can keep space safe for everybody to use. And then the technology to accelerate. Space is a really interesting place in that, because there's no maintenance possible, once you launch something or launch a satellite, that's it. It has to work, and it has to work for however long the lifetime of the satellite is, which can vary from a couple of years to 20 or 25 with absolutely no maintenance. And so we, as an industry, are sometimes very reticent about changing anything. If it has on-orbit heritage, if it has space-qualified parts, you want to keep them. And at the same time, we really want to advance and change and put new innovation up. So some things will adapt quite fast and some things will adapt quite slow. And that's a really careful balancing act when it comes to new space projects.
And if we were to look further into the future, especially for young people listening to our conversation, maybe they're feeling inspired, listening to our conversation, opening their minds to new job roles that are beginning to emerge. Are there any particular roles that you see emerging? Do you see emerging space technologies playing in everyday life and indeed broader societal challenges as well?
There are so many that it's hard to list them all, but I'll pull out a few. You mentioned GPS. And we have the European system Galileo and many others, and that permeates daily life in not just in satellite navigation and phone and tracking everything, but actually the timing signal is used for things like banking, and every time you use a cash machine, for instance, it picks up something from the GPS signal. We are seeing new connectivity systems come on board. You've got Elon Musk's Starlink, Amazon are designing a system, the UK has OneWeb. They're all providing internet connectivity in a way that didn't exist before, which is going to connect people around the world in a way that hasn't happened up until now. And it is allowing some countries even to leapfrog whole technologies almost. So to get that constant communication, in the past we had to cover the UK in copper wiring for phones, but countries don't have to do that anymore. They can go straight to satellite technology. And so there's really a space for, with these technologies that are being developed, what else can you do with them that hasn't been thought of today? We've seen a surge into telemedicine, and if you can have that live connection that you know is very stable, you can talk to people in other parts of the world, you can share information, you can help do operations differently. But really, the roles that are emerging that are exciting are the ones that we haven't thought of yet. It's the what can you do with all of this new technology that can benefit society, and hopefully there's some really exciting things out there.
I think that's a powerful moment to end on. But before I do, I cannot thank you enough for coming on here, taking the time to share your insights and give us a different vantage point into space technology. But I'm going to see if there's something we can do for you now, because some of the biggest names in business, VC funding and tech have either been guests or maybe even listened to this podcast. So if there is one person that you'd love to have a private breakfast or lunch with, who would it be and why? He or she might just be listening to this, so let's see what we can manifest together. But who would it be?
Well, this is a really interesting one to think about, because so many names sort of popped into my head. Yeah. But actually one that stood out was Peter Diamandis, who founded the X Prize and has done a lot around space exploration and advances in the US. And I picked him because I have met him before, but a long time ago. As a student, I did a summer placement and I worked supporting a startup company he had way before its time. That sadly, the funding didn't work out. But things have changed so much, and over the, more than 20 years since I worked for him, that it would be fascinating to meet up again and see what things have changed, and also to sort of learn some of his tips and tricks, because he's done some very impressive things across the industry. So yeah, Peter Diamandis would be my lunch choice.
Well, fantastic. And so I will add that. We'll throw it out into the ether, into the universe. Let's see what we can make happen there. And for anyone listening, just wanting to find out more information about some of the space projects that we were talking about, that incredibly cool space apprenticeship, or just finding out more information online or connecting with your team, where would you like to point everyone listening?
So we have a great website. If you go to the basystems.com, and if you look up Space Insights, we do a regular newsletter on all the things that we're doing on space. Also on there, you can find details of the space apprenticeships and how to apply. And then our LinkedIn presence has a lot of information as well, and we post quite a lot there.
Fantastic. Well, I'll get that link added so people can find you nice and easily. And I think we covered so much in a short amount of time today, from the role of space in defence, the need for Earth observation and real or near real-time intelligence for multi-domain operations, but also exploring what that means for the future of innovation in space and how here in the UK you can exploit dual-use capability. And not to mention finishing on that first ever space apprenticeship, which I'll be checking out in a moment, even though I'm way too old for it now. But thanks so much for sharing that with me today.
You're very welcome. And you're never too old to join the space industry, although maybe not as an apprentice, but we welcome people from all walks of life. So absolutely, anybody listening out there who wants a career in space, please do have a look and see what you might do.
So as we conclude our discussion with Liz today, I think it's clear that the future of space and strategy and market development, collectively, it holds immense promise and potential. From that groundbreaking Azalea project to the launch of the UK's first space engineering apprenticeship, it feels like BAE Systems is at the forefront of innovation in the space sector. And I think Liz's insights into the dual-use capabilities of space technology, along with the critical need for Earth observation, I think it really painted a vivid picture of how space will continue to impact both defence and the civilian domains. But I want to hear from you. What excites you about the advancements in space technology? How do you see the role of space evolving over the next decade? Please email me now, techblogwriter@outlook.com. But that's it. Time for me to beam myself out of here. So thank you for tuning in. Remember, stay curious about the cosmos and the endless possibilities that it holds. But until next time, keep looking and imagining a new future of space. But thank you for listening as always, and until next time, don't be a stranger.